So hi, we'll be exploring more on different techniques to generate structured mesh in ICEM CFD. That is a meshing software we've been exploring for so many days, and I think this video I'm gonna upload after very long. And so now we'll be performing some different kind of technique. We'll be looking at different kind of technique that can be used as meshing technique, and there's not very a very different technique, but it's kind of the common sense that you need to know, and if you go through that, that will make your life easy. That's kind of common sense you should work on, and I think you'll be getting more intuition how this O-grid is basically how that works, and what is the fundamental behind that O-grid thing. So basically we will not be doing O-grid, but we'll be looking this O-grid thing in a different way. So it's kind of O-grid that you can generate without using an option of O-grid, and that is not really an O-grid. That's a part of partial O-grid, you can consider it to be. So we'll be meshing a pipe bend, and that's gonna be the geometry for this tutorial. So as usual, we'll be going through this geometry tab, and we'll be going to create point, and we'll be creating some points. So for the time being, I'm gonna show you what kind of geometry, or what kind of domain we'll be exploring. So basically, or maybe you just can consider like this. Maybe here it's a pipe. You can say it's a pipe bend, and we can say here I'm constructing this. So yeah, here is the pipe, which will be having some dimensions. I'm gonna tell you. So it's a rough sketch. Basically, it's not to the scale. It's an approximation of the pipe we're gonna explore. And the dia. It's a 2D problem of a pipe bend, and you can consider it to be a two-dimensional pipe. So it's basically the diameter, and diameter will be, we can consider it to be 0.1 meter. This we can consider to be maybe we just can say 1 meter, and the other one, this vertical height from here. This also you can say to be 1 meter, and this radius, maybe you can just say, so this is the point. This radius you can consider it to be maybe equal to the diameter, or I think it's good to have it to be equivalent to the diameter. So these are equal. And because this is equal to the diameter, so it's more likely to be, or you can say this is D, because this is D, so it's gonna be D here, and this one also is gonna be D. Okay, so it's gonna be 2D as total. So, but basically this D is 0.1 meter, so it's going to be 0.2 meter here. This much. So it's a big explanation, but basically you understood it. And yeah, of course, we need to know the coordinate points to locate an ICEM. So I'm gonna click over this. I can consider this to be 0, 0. This point, of course, will be 0, 0.1. This is 1, 0, and this point, this is gonna be 1, 0.1, and of course, because this is 0.1 height, and this bend will give it as a height of 0.1 meter, so it's basically 0.2. So, and here it's 1.1. This is 1.1 in x direction. So 1 is gonna be 1 point. Sorry, not 1 point. 1 comma. Basically, this will be 1.1 and comma 0 because y is 0. So I'm gonna click over. Not click. I'm gonna just assign the points. So here the coordinates of this point will be 1.1 comma 0.2, and for this I can put an arrow so that you can differentiate. So it will be 1.2 and this is yeah, the height will be of course 0.2, and then because this additional height, okay, yeah, sorry, one more thing I just need to tell you is that this height is 1 meter, and then of course these coordinates will be, you can say, because this is 1.2 and this will be added, so it will be 6.2. Oh, sorry, not 6.2. This is x coordinate 1.2. For this x coordinate will be 1.1, and then height will be 0.1, and this 0.2. 0.2 plus 5, that means 5.2, and again of course 5.2. So these coordinate points you know. Now I need to locate in ICEM. So I'm going to go over this XYZ coordinate system, and then I'm going to put 0, 0, 0, and the next of course will be 0.1. Then one point is 5.1, and of course I can click over this fit window so that I can see this pipe here. Then what I'm going to click over, oh sorry, that was 5, that was not 5. Can delete the point. That was 1 actually. So that was not 5, that was 1. So I'm going to click over this, and then I can relocate, or I can just, you know, pan to the best fit. And I'm gonna click over, I'm gonna assign this y equals 0 so that I can create the full point. And I'm gonna click over apply. Then what I'm gonna do is I'm gonna put these 1.1, 0.2. So 1.1, 0.2 I've applied. The same way 1.2, 0.2, as you can see here. This is 1.2, 0.2. So here. And the next will be 1.1 here. This maybe you can see here. 1.1, 5.2. 1.1, 5.2. Say apply. You can see here. Okay, it didn't get applied. Sorry, I think again I just made a mistake. That was not 5, basically. That was 1. So I made a mistake. So maybe because this was 1 meter, so it was not 5, sorry. So this was 1.2, and this is also 1.2. So 1.1, 1.2. Okay, 1.1, 1.2 applied. Then again 1.2, 1.2, and then say apply. Now I'm gonna make a circle. Maybe this circular, or maybe in the arc. You know, this is a quarter circle. Will be available here. So first of all, I'm gonna create this simplest geometry. Join these curves, these points to build up a curve. Straight curves. So one. Now left with this bend. So if I, you know, create this bend, so we need to know the center point. So here, as you can see from here, you can maybe simply get to know about this point, what the point is. So the point will be here. This is 1. So x coordinate will be 1. Then what about y coordinate? Y is 0.1 plus 0.1. So being added, this becomes 1, 0.2. So here I'm gonna assign this point. I'm gonna create. This is 1, 0.2. Say apply. So this is the center I got now. Then I'm gonna click over this curve, and I'm gonna make this circle. I'm gonna select circle or arc. This is the third option. Clicked over here, and maybe you can just drag it up a bit so that I can see. So because I want to make 90-degree angles, I'm going to enter over here the angle value, and now I'm just asking for 3 locations. I'm going to click over this center, first location, the second location, and the third location. So I get this point, this arc. The same way, I'm going to click over the center, the second point, and then of course here. So I got this bend. Now I can delete this point because this is useless for me now. I can delete simply, and then I got this pipe bend. Now I'm going to create the part. So maybe you can just assign it to be the inlet, this is to be outlet, and these can be, you know, some walls, pipe walls. So I'm going to click over this part, right click, and then create part, and say the inlet, and click over this entity, middle button click, so it got created. You can expand this to just to see whether this got created. So we got this inlet. The same way, I'm going to click over this, enter here outlet, and then I'm going to middle button click. The same way, this, and this can be wall up. In the same way, this wall down. I can say wall down. So middle button click, and then just simply once more to get out of this command, I need to click. I need to click the middle button. So now I got this wall down, wall up, outlet, and inlet. Of course, these are for boundary condition we just need. Now, of course, we'll be going to the blocking process, and then what I'm gonna do is I'll click over this entity and 3D bounding box. I just selected and clicked the middle button. Now, basically, you can consider this geometry to be, you know, the 3-part, and I'm gonna create this block in a different way. I'm gonna give a bend to the block itself. So how do we do that? I'm gonna create a single block here, vertical, just like okay, let me show you. I'm gonna split this, and simple split I'm gonna do. First, you can select this prescribed point simply, or maybe you just can leave it blank, but that I feel much better this option. So prescribed point, so that you can get to know which point you're gonna select. So this edge, and of course any point of this point, this point. Maybe I'm gonna click over this. So I got split it. Here you can see this is the vertical block here, vertical edge here. So what I'm gonna do is I'm gonna delete this full block, this one, this block. So if I delete this, I get only one block vertically. So what the technique will be, how to do so? You can consider this to be in a 3-part. So a rough sketch I'll be making here. This is a pipe bend we've been talking about. Simply, and of course this is the block we have for the time being. Right now we have this block. So as you know that this is a point, Okay, here, this point, we do have this point, we have this point. Okay, and these points as well, we do have. So I can just, divide this geometry in 3 different parts. So this is one rectangular domain. This is the second part. This bend part. This part is the second part. So I'm gonna assign part 1, part 2, and part 3. This vertical pipe. And what I'm gonna do is I'm gonna apply a technique. I can give a bend. I can split this the block. Okay, this is the geometry, and this is the block we have now. So I can split this block into 3 different parts. I'm gonna associate these different parts of, or maybe the blocks. So this is block 1, this is block 2, and this as the block 3. So what I can do is maybe you can choose a different convention so that you can get to know you can better understand B3, B2, and B1. So block 1, block 2, and block 3. So what we do is we simply associate block 3 to the part 3 of geometry, the same way block 2 here to the part 2, and block 1 to the part 1. So how do we do that? Simply you can associate this vertex to this point, same way this to this, and now this point to this, this vertex to this point, again the same way here, this association. And now here you need to apply some brain. You can just, or maybe you got to know what I'm talking about. This point, you're gonna give a bend. So this point will be associated to this point, and this vertex to this. The same way, this will be associated to this one and this too. This. So now this is a technique to bend the blocks itself, the block. So looks complicated, but this is simplest way. Or maybe you can just use all grids somehow. The other way, as we've seen, how do we use this all grids? But this I found to be the best one, or maybe the easiest method. How we can, create. So I'm gonna show you how this works. So first you split random. You can just close it. Screen select. You can select. And click here. Say middle button, and click here. Say middle button. But now, of course, as we've seen, that this point is to be associated to this one. So what I'm gonna do is go to association, and the first option is associate vertices. So I'm gonna click over this. I'd say I'll select this vertex and select this point. Got associated. Good. The same way, this vertex is to be associated to this point. I've associated. Now, the technique is to move this vertex to this point. So click over this and select this one. The same way, this vertex to this point got bent, but what is still remaining? These two. So what I'm gonna do is I'm gonna select this vertex and this point. Got associated. This is the remaining one, so the same way I just associated this. Okay, set middle button to come out of the command, and then what will I do? I'm going to show you how this the blocks, this arrangement of this bending looks like. So I'm going to just switch this geometry off, and this is this is the blocks remaining here, part 1, 2 and 3. So these are the blocks. So to work out with this example, I'm gonna simply associate the curves now. So associate curves, edge to the curve. So I will simply select this one as we used to do. Associating this this edge to this curve. Same with this to this. Now this edge to this curve, this edge to this curve, and the last one here. Okay, we got associated. We got these edge to the curve association, and finally we'll be moving forward to providing or just the input for the parameters, how many number of divisions we want of the nodes. But before that, people think I've encountered people asking me question about why did we do this association. Okay, that's okay for the simple geometry, but I mean it's not simple. This curved geometry, because that association requires some mapping, but we've seen in the very first example that this is the geometry, simple geometry. It's a kind of a block, but again, what do we have is the overlapping. Maybe you just can consider making it a bit bigger and just random. It's a block, and that will exactly coincide with this geometry. So black geometry and the red one is the block. So the problem, like the question what people ask me is that why do we really require this mapping, because it's already a block kind of geometry. Can we directly mesh? We can generate, of course we can generate a simple mesh directly. We can generate now without even associating. We just can simply give parameters and we can generate a mesh. But there are basically two reasons. First is mapping, of course, but this has already been mapped, so it doesn't require mapping at all. The second most important factor, which people ask, what the main reason for these kind of geometries, even for simpler geometries, this blocking association is required. So the second reason, and one of the main reasons for this association, is the transfer of boundary conditions. Transfer of boundary conditions. What is that? So transfer of boundary conditions means because this association takes place, or when this association is taking place, those boundary conditions we have named, we have assigned some names to these curves. Say this was inlet of the domain, there was outlet, this you can say upper wall, and this can be the bottom wall. These boundaries are these are available in the domain, the geometry. But these don't get transferred to the block till you associate. Unless you associate these curves to the edges won't be assigned as with the boundary conditions. So this this block what you made, this doesn't have information about these different boundary conditions that you assign to the geometry. So it will simply be meshed up, and then you transfer the mesh. You won't be able to see those boundary conditions in the fluent mesher, or wherever you require this mesh to be available. But these boundary conditions will not be available in that mesh because you haven't mapped, or maybe in some other terms you've in other words, you haven't associated, or you haven't transferred the names of these boundaries to the mesh because you have not performed association. So that is the base, that is the base of mapping or association. That really requires your attention, and that is one of the main two reasons why we do this association. Okay, leaving this talk just here, and what we'll be doing next is simply we put some give the parameters. Simply go to this under blocking tab, we go to mesh parameters and pre-mesh parameters, and we go to this edge parameters. Now what I'll do is we can copy the parameters as we usually do, and we can say we can select this parameters. So now you can see that just as we've seen that under O-grid blocks, you can see those curved that rotating edges being treated as as the parallel edges. I'm going to show you here. So this is the O-grid block that I'm talking about. Say this is the O-grid, and you've seen that these edges are treated as the parallel edges. So this is the concept behind that. Actually, this is rotating. So this is a kind of a bend in a single mesh. If these are 1, 2, 3, and 4. These are 4 blocks. You can just consider this to be 4 blocks. 1, 2, 3, and 4. And you can rotate the same way we rotated. So this was the base of this O-grid block. So O-grid is a kind of complete 360-degree rotation. We just had here a 90-degree rotation. You can see here, this is the 90-degree rotation of the O-grid mesh, you can say. So it's kind of a manually construction of O-grid mesh. So now we got to know why did we do. So of course, this edge you can see here, this, this. Of course, these two are parallel, but this will be considered as parallel because this was originally parallel to this one. Or maybe you can see this and this. All of them are parallel originally. That's why these are being considered to be parallel edges. So now what I'm gonna do next is, of course, putting number of nodes. I can say 10 nodes. Simply just look at how this mesh gets generated. And next, of course, some parameters to this. I can say maybe 100 nodes I can plug in. The same way here also gonna plug in 100 nodes. And here also I can simply tell this to be maybe 20 nodes will be perfect. And what I'm gonna say, simply click over this pre-mesh, just look how it looks like. Yes. So now you can see that we've generated a mesh, a uniform mesh almost, and that here a bend has been mapped perfectly. Bend mesh has been generated. So you can see that how perfect mesh we've generated. It's a simple mesh and a simple way we've generated without using an O grid. And this is a much better technique whenever you find such kind of geometries, such kind of curves. So you can simply bend the mesh, the blocks itself according to your geometry. So that was a kind of technique. So I can just simply save this project somewhere, maybe CFD practice tab, and 2D pipe bend again. Pipe bend. I'm going to construct this folder, then say open, and simply save it with some name, random name, a project one I just saved. Now I'm going to construct pre-mesh and then convert to unstructured mesh as required by Fluent solver. I'm going to click over this output as usually we do, just like we do, and simply say apply, and this is Fluent we need, and of course save, and then I can just select this project one.he unstructured file. It's a 2D mesh. I can give a name, better name, pipe bend mesh, whatever you select, that's up to you. I'm gonna say yes, and then I can close it, say yes, and now I can test it whether that works with Fluent Mesher. I'm gonna open this in 2D mode, say start, and I'm gonna read this mesh file here. I'm gonna click over this file, read mesh, of course, and that was under CFD practice, and it's a pipe bend that we've saved. So I'm gonna double click over this to read. Now you can see that it's can be seen here. So let's just check if something's wrong with this. Cell zone conditions, of course, fluid, and we just can change if that doesn't get changed automatically, because it got detected because of these boundary conditions. It got detected as fluid because fluid zone, because boundaries are having some names, inlet, some outlet, and the walls. So it considers this to be something kind of fluid zone. If it doesn't get selected, if it is set as solid, the type is fluid, name only is solid because we initially we selected as a 3D bounding box as a solid. We didn't change over there as a fluid. So the name you give there gets here. You can simply edit this. You can give some name, better name. Maybe you can say a fluid. Apply, and then click over close. This is fluid. Okay, that was now the topic of interest. The topic of interest was that if we get the boundaries here, so inlet, of course, outlet we got, and then wall down and wall up we got all the boundary conditions here, so it can be read here. That will work for your case if you have such a case. So that's all for this tutorial. Thanks and bye. Take care.